Let's take a look at some more examples of factoring trinomials. This particular method is not one that's in the book or on the videos on my math lab, so I want to make sure you have enough to reference as you go through the homework with the practice. So remember, we're talking about factoring trinomials, tri meaning 3. So in these examples, we're going to be looking at 3 terms. So 1, 2, 3 in this example here that we're going to take a look at. So to get started, we look at the coefficient of the first term and the constant in the back. So the first and last, and we multiply these together. 3 times -8 is -24. And we're going to be considering factors of -24. So let's identify that with the F. Next, we're going to be taking a look at and considering this coefficient here from our R linear term, 10, and we're going to be looking for factors of -24 that add to a positive 10. So factors of -24 that add to 10. So in this particular example, because we're multiplying to a negative number, one of our factors is going to have to be positive and the other is going to be negative. So 24 happens to be a number that has quite a few factor pairs, so we could start with the most basic 1 and 24, and as I just said, since this is multiplying to a negative, one has to be positive and one has to be negative. And since we're adding to a positive number, my suggestion is going to be let the bigger factor be positive and the smaller factor be negative. -1 times 24 is a -24. -1 plus 24 is 23. That is big, way bigger than the 10 that we want. So then we might consider, there's 3 and 8, there's 4 and 6, but we'll go in order. Let's try 2 and 12. And again, I'm going to make the smaller number the negative number since we want to add to a positive number. -2 times 12 is -24. -2 plus 12 is equal to positive 10. Eureka, look at that. We have the factor pair that we need. Let's make our factors. We need R is our variable, R squared, so we have R and R. Now we take these two factors that we found that works, and we're going to put them in here, R minus 2 and R plus 12. Looking at this, we don't want to R times R is R squared. We don't just want R squared. We want 3R squared. So we are going to take each number in the back and we're going to divide it by this 3 here. So this 3 is going to go there and it's going to go there. As always in math, when we have fractions, we want to simplify them. R minus 2 over 3, there's nothing we can do there in terms of reducing or simplifying, but over here 12 divided by 3 is 4, so we have a nice clean R plus 4. Almost done, but not quite, because when we do the division, if we have a fraction that's left, we want to clean this up, and so we're going to take this 3 and we're going to move it in front. So we're going to have 3R minus 2 as one of our factors. And now R plus 4, this 4 is simplified, nice clean whole number, so no need to move any denominators there. We don't have a denominator, and this would be our final answer. 3R minus 2, R plus 4. Continuing on with this next example, again, we're going to start the process by multiplying the number here and the number here. Our coefficient here is that invisible 1. So we have 1 times 5 to give us 5. And we're going to be considering the factors of this 5. Now, what about the number here. We go to our middle term, -7, and this is the number that we want our factors to add to. So, 5. We have the factors of 1 and 5. 1 times 5 is 5. 1 plus 5 is equal to 6. Well, that doesn't work. 5 is prime. The only factors are 1 and 5. We are adding to a negative, so we could try -1 and -5. -1 times -5, we get our +5. However, when we add -1 plus -5, we get -6. That doesn't work. In a situation like this, when you have exhausted all the possible factor pairs of the number, in this case, we were fortunate in that 5 is a prime number, so we didn't have too many to consider, then this is a situation where we are not going to be able to factor, and we call this prime. So there is no factorization that's possible.